All right, today we're going to discuss on critical path method. All right, so last week we have discussed on PERT, um, program evaluation review techniques. So that's one of the way we just estimate that mean, variance, and some deviation in order to analyze that activities. All right, today topic we will cover on the critical path method. All right, so this is something you need to understand and focus on because will be very important for your future, career, and will be usually implemented in order to execute any of the projects. Okay, say for example, your project manager. So you may know how to estimate the project entirely and what is that element you should consider and you should not consider. Okay, so it's what we're going to look into this today lecture. There we go. Okay, the outline of the learning objective for today topics will be on the concept. Okay, the concept of the critical path and then the critical activities. And then we're also going to learn about the location of the critical path. Okay. And then we will do evaluate the project completion times. Okay. Besides that, we're going to look into that. What does it means the float and slack? Okay. And then uh, what the criteria must be in order to fulfill, and then in order to make a successful project completion. All right. So this is what we're going to discuss today. All right. All right. First thing is you should know that the critical path methods is a main objective is in order to determine the time to the complete the projects. Okay, this is that very important. So in order to complete the project, so the time is crucial. So critical path method or CPM will be determine the best estimation time you can complete the project or task, right, on time. Okay, so usually it's conducted by the managers in order to draw their project activity. Right. As we know, the CPM is assumed that the precise time estimate which is available for each activity. So we're going to calculate how long each task or activity or will be estimated. Okay, in order to complete successfully. Okay. All right. From the start event to the end events, so we know that the time required to complete all the activities of the project in the specified sequence known as a project completion time. So this is the definition of the project completion time. So it has to be specified sequence based on that the allocated time for the particular activity in the entire project. All right. A continuous sequence means that it consists of the nodes and the activities alternatively, beginning with the start event and stopping at the event of that the network is called as the path in the network. So this is the definition of that path in the network. So you should understand the difference between that the project completion time and path in the network. So these are the differences. All right, now take a look on the critical path and activities. Okay. Consider all the path in the project. We know that is beginning with the start event, okay, start event as well as the stopping event. Okay, so we have the two. You must have it. All right, start event and then the stopping event. You should have that the criteria. Okay, and for each path, okay, it's calculated the time execution. So how long does it takes for time to complete a particular activity? By adding the time for the individual activities. Okay, so by duration of those path, we will need to calculate the time of the execution as well that we need to adding the time for that the individual activities in the path. So that you can easily can calculate along with the each path. Okay, usually the path with the largest time, that means the path which has that, for example, the greater time period is also called as a critical path. Okay, I think we already covered in the PERT last week. So last week we have a cover in the last lecture. We have a cover on that, the critical path, how you calculate. So usually it will be longest time in order to complete the project. That is defined as a critical path. And the activities along with this path are called critical activities, and then, or we also call as a bottleneck activities. Okay, because each activities in the critical path, so that we call as a critical activities, because that is a very important, and sometimes it will be affect that the entire project completion. Okay, so you know to understand that. All right. The activity are called as a critical because they cannot be delayed. This is important because each critical activity has that specific time in order to complete. If any delay of the project, it will be affect that entire project. Okay, so that is very important to know. Okay, so it cannot be delayed. It cannot be delayed. So that is we call as a critical activities. For any delays, okay, for the critical activities, will delay that the completion of the whole project, as I said earlier, right? So it will affect that the entire project overall. So you need to be very careful when you're dealing with that, the critical activities. All right. So it's also is good for a project manager, okay, in order to pay that special attention on that the critical activities, make sure it's been done, you know, on time. So say, for example, you are manager of there's a certain project or task that you carry out, you need to pay attention on that the most difficult activities in that the entire project. So that particular part is a very important in order to complete on time. Because if you delay any of the particular critical activities, it will affect your name, and though it will be lost that your project in the future. All right. And you'll be get up some penalties as well. So you need to very careful when you just make the plan. All right. In CPM, we have some terminologies we need to use. So that is associated with that in order to calculate all that the measurements. All right. First is all you need to know is that earliest time, start time. Okay, earliest start time. So usually the earliest time is denoted by the capital E. Okay, usually denoted by capital E, and it will calculate forward pass. Okay, it will be calculate towards the forward pass. Okay, so which means the earliest start is defined as that the earliest possible commencement of or time of the project. Okay, how fast the project is can be started. Okay, that we call as a earliest start time. Okay, second is latest finishing time. Okay, usually the latest finishing time is will be calculated from that backward from that your networks. Okay, you calculate from that backward from your network. Okay, so it is also refer the maximum time and activity can finish without impacting the final project completion time. Okay, so now you already know that the earliest time and then latest finishing time is always come after the project, the following project. Okay, you need to calculate based on that. Next, earliest finish time. So earliest finishing time, okay, you can be calculated based on the formula, which is usually the earliest finishing time is given in the symbol of TEF. So it is an earlier finishing time. Okay, earliest finishing time, which is equal to your earliest starting time. Okay, earliest starting time plus with that the duration. Okay, the duration of the project. Okay, earliest starting time plus that earlier the duration of that the project. You should remember. Now, latest starting time. Okay, latest starting time is also can be calculated, denote as the TLS. Okay, TLS, which is latest starting time, is equivalent to your L, which is latest finishing time. Okay, so you can refer to that latest finishing time minus, remember, minus the duration of the project. Okay, minus the duration of the project. So if you subtract the duration of project from the latest finishing time, then you can able to get that latest starting time. Okay, so please remember all these terminologies and definition, so that it helps to calculate the CPM. Okay, moving on. Now, in this section, we also learn about the float and slide. So what does it mean, float and slide? The float and slides is defined as that realization time. Okay, so realization times, which is how long the project can be delayed or can be relaxed, maybe 1 day or 2 day. Okay, at least permitted. Okay, based on calculation, we are able to identify the realization time. Okay, so that's calculated based on that, the float and slide. And the realization for activity is also called as a float, whereas the realization for the event is called as a slide. Okay, for activity they call as a float, for the event they call as a slide. Okay, let's see that all the formulas we use that the float and using a slide. Okay, first thing is you should understand maximum available time. Okay, so how are you going to calculate the maximum available time? It's very simple. In order to calculate the maximum available time for the one activity, so you can use a formula, which is your latest finishing time minus with that earliest starting time. Okay, so you need to know that. So you know, right? The formulas here, latest finishing time, L minus earliest starting time. So this is what is written here. Okay, you need to understand the concept. Okay, now we're going to calculate the float. Okay, so in order to calculate the float, we have a formula. All right, so total float. Okay, total float denoted by the TF, which is equal to this maximum allowable time. Okay, L minus E minus the duration of the project. Okay, TJ, the duration of the project, which is can be also can illustrate using the formula, which is, as we know, that LE, right, the maximum allowable time, also being calculated from that your latest starting time. Okay, the formula we obtained before. Okay, so here, all right, this also can calculate from here. Okay, so TLS minus E, or we can write the other way around, L minus E plus, okay, the earliest starting time plus the duration of the project, or we can express in this form, which is latest finishing time minus your earliest finishing times. Okay, earliest finishing time. So the formula, you can choose either this formula or this formula in order to calculate that total float. So later I will give you one example. So we will go discuss in detail. We can calculate, identify how we are able to solve the or calculate the total float using these formulas. Next, we're going to calculate the free float. Okay, the free float. So in order to calculate the free float, okay, the formula is, we usually denote with the FF, free float, equal to total float, the one you obtain here, the total float, minus with that head event slide. Okay, the head event slide, how you get from that maximum available time. So L minus E. Okay, I'll even show you later. 8 event slide. So if you say this is your network model, okay, so the 8 event slide you can calculate from here. Okay, we calculate from here. So you know that the E and then the L. So based on this information, we are able to calculate that the L minus E. So we are able to calculate that the head event slide. Okay, the free float. Okay, the free float is also a part of that, the total float, which is not affect that the successive event or the activities float. Okay, remember that. All right, next is independent float. Okay, so independent float, usually we denote with that IF. Okay, the formula for the independent float is your free float minus to that tail event slide. So tail event slide is this part. Okay, So say this is, you have another EL, so L minus E. So you get that the value from here in order to get that the tail even slack LE. Okay, it's also a part of that total float, which is not affect the preceding event or activity float, which means it will not affect that whatever the value obtained independent float, it will not affect that the preceding activity, which is the activities before this. Okay, the activities before this, it will not affect any activities. Again, so the free float, whatever the activities after will not affect. Okay, will not affect that the successive event. So say you have another activity here, successive event, it whatever the float obtained here, the free float, it will not affect that the successive events. This is how you need to identify it. Okay. Now next is the interference float. Okay, the interference float, usually they denote INT F, the capital F, which means interference float, which is equal to total float minus that the free float. Total float minus the free float. So you will get that the interference float, which means the float which is anything beyond on that the particular numbers or the amount, it will definitely affect overall that the project come after this. Okay, it will affect that overall project come after that event, the particular section of the event. All right. So this is that the four formulas, all the four plot you need to remember. It's very important in order to do a calculation. Okay. All right. Now, critical path. I'm sure you all know about the critical path. Okay, the critical path is the longest path in the projects. Okay, so this we already covered in the last lecture. Critical activity as well. So each every activity in that the in the critical path, as we call as a critical activity. Okay, so each activity in the critical path we call as a critical activity. You must remember that the total float values for the all four float are 0. Okay, if it is we calculate the total float for the critical path activity, you will obtain the 0 value for the float for all the float, the total float, free float, independent float, and interference float. Everything you will get a 0 value. Okay, subcritical activities also define that. Say if the value for the all four float are more than 0, it suggests that the activity has some flexibility or slack. Okay, so which means you can delay or can delay the project maybe 1 or 2 days, depends on the value obtained. And its completion would not impact that project overall duration. So which means it not will affect that the overall project. Okay. All right. Supercritical activities. Okay, supercritical activities means that if a value for all the four float, okay, I told you right, the four float, okay, total float, free float, independent float, and interferent float. Okay, so if all the negative is indicate that the activity time sensitive, and if any delay in the completion would directly impact the overall project. Okay, the supercritical activities have no flexibility. Okay, there is no flexibility, and any delay in these activities, you should extend the project completion time. Okay, so that's the four type of that the critical things. All right, you need to know that in the CPM. All right, now take a look at this example. Okay, so please pay attention clearly. So I will do the step-by-step approach, how we need to calculate each every one of it. Okay. All right. So the activity is given. All right. So activity 0 to 1, all right, is given a 2 days duration. And then activity 1 to 2, they given 8-day duration. And 1 to 3 is a 10-day duration, and so on until each every node points to the particular nodes. They give that the number of day of the duration. Okay, now first thing, what all you need to do is you need to develop that network. Okay, the network model for that the given data in that table. Okay, so in order to draw this, so you need to address. So you can say that Okay, from 0 to 1. So 2 days will be consumed, the activity, in order to run from the node 0 to node 1. So it will take 2 days. So we can assume that this is activity A. Okay, you can assume that is activity A. Okay, so activity A. So between this 0 to 1. So activity A. All right, next from 1 to 2. So 1 to 2. Okay, from node 1 to node 2. So it will take 8 days. So you can assume that this activity B. Okay, so activity B, and it consume 8 days. Okay, it's consumed 8 days. Okay, so for the node 1 to 3, okay, from node 1 to 3, so it will take 10 days. Okay, so you can assume that is a activity 3. Okay, you can denote that is a activity C, and it will take 10 days for the duration in order to complete. Okay, so likewise, you need to link to each every activities. Okay, and you need to denote that the activity name for the each connection of the nodes, each age. Okay, you need to give that the letter of the activities. Okay, so A, B, C, D, E, F, G, H, I, J. So we have a J activities, and then we have a the number of day completion of that the activities is given according to the given set node. Okay, right. Once you've done this, okay, next we move to estimate that the earliest starting time and latest finishing time. Okay, as I said earlier, the earliest starting time is must be calculate from that forward pass. Okay, you calculate for forward pass. Okay, forward pass. So we calculate from the beginning. All right, so we calculate from the beginning. So we're going to calculate earlier starting time. The early starting time at this point. So usually at this point we need to denote with 0 because we about to start. Okay, this because earliest starting time is must be 0. Okay, all right. Next, moving on from here at the node 1. So earliest starting time will be 2, which means you take the duration of the day. Okay, from the earliest starting time. So 0 plus 2. Okay, you will get a 2. So that's how you get that earliest starting time at that node 1, which is equal to 2. Okay, you need to add them together. All right, 0 plus 2. So you get a 2 days. Okay, 2 days. Okay, so here you need to obtain this value. Okay, so this is how you need to get 0 plus 2. Okay, you get a E into 2. Okay, next we're going to consider that node 1 to 2. So activity B. We're going to calculate what is the earliest starting time from the activity B. So we get that E equal 10. How you get that? So 8. So you already get the 2, right? So 2 plus 8. Okay, 2 plus 8. So you get a 10. So that's how you get a 10 here. Okay. Okay, you get a 10 here. All right. And then moving on. So in order to calculate that the earliest starting time for the activity F, so very simple, take that 10, you plus with 3. So 10 plus 3, you get a 13. So at this point, activity F, it takes 13 days, okay, in order to complete. Okay. Now, next, you cannot come here because we have the 3 other the path is involved. Okay, so 2, 5, 8. So we cannot calculate that the earliest starting time at this point. Okay, at the point I, because you need to take that the maximum value of that the value up here. Okay, the maximum value what you get up here. So you need to write down here for the E. Okay, so for now we do not know what the maximum value of that at this section. So now in order to calculate that, we need to go for that other path line. Okay, other path line. Okay, now, so now look at that, the 3 now. Okay, the node 3. So again, in order to calculate that earliest starting time at the node 3, it's simple. So you know that is a 2 from 0 to 1. It's a 2 days, and 2 days plus 10. Okay, It's a 12 days. So you just get the value here. Next, we have a two option. One is H or E. So we calculate that year first. All right. So here, as we know that there's a two type of it. Okay. First is from this option. Okay. This option, which is A, B, D or A, C, E. Okay. As I said earlier, we should take the maximum value. Okay. We take the maximum value or maximum earliest time. Okay. So earliest starting time, which is maximum. Okay. Now we calculate this. So here we got a 12. All right. 12. Okay, 12 plus 3 is a 15. Okay. It's a 15. But if you calculate from here, so you get a 10 here. The 10 plus 6 is 16. So this is the maximum value. So then we should stick with that, the maximum value of that earliest starting time. Okay, so just you write down that the earliest starting time, which is 16 days. Okay, all right, next. Once you just get it this, next you need to calculate that note 6. All right, so for this is simple. So we know that the up to the third note, the earliest starting time is 12. The 12 plus 7 days, so you get a 19. Okay, so 12 plus 7, you get a 19. So you can write down here the earliest starting time at the note 6. This will be 19 days. Okay, next. So once you just done it, you need to calculate what is the maximum value. Okay, if it is 16, okay, so we look for the first option. Maybe you can take this first. Okay, the 13 plus 2, we got a 15. So E15. Okay, the first option, if you just follow this path, you get a 15. Okay, so now we take the another option, this path. Okay, so we have that the earliest starting time, which is 16 years. So 16 plus 5. Okay, 16 plus 5 is a 21. So and this part we get a E. The earliest starting time is 21. Okay, but if you follow this path, so the 19. So 19 plus 8 is a 27. Okay, so E is 27. Okay, so sorry there. All right, so now you need to compare which part is take a longest time or maximum time. Okay, obviously you can see this 27, right? That means we need to stick with that. We need to choose that the maximum time of that part. Okay, so you can delete the rest. All right, so this is how we need to find that earliest starting time from every part. Okay, so this is a maximum 27. Okay, all right, now in order to calculate latest finishing time, okay, latest finishing time, we need to calculate from the backward. Okay, so latest finishing time, you need to go for from that backward. Okay, backward pass. Okay, so now, so you should remember that the latest finishing time must be balanced. Okay, 27. Okay, must be balanced, which is 27, as well as year. Okay, right. So just the 27 there. As well as that, you look at that, your 0. Okay, at note 0. So the latest finishing time should be L equal to 0. It must be balanced with the both side. Okay, but however, first you need to set up this first. Okay, then you need to do the calculation from the backward. Okay, backward. Now we're going to calculate one by one. All right, so we're going to determine that backward calculation in order to set that latest finishing time. Okay, means that in order to complete the task F, you need to look at the successors, the successive task which is here. So which means in order to get the successive task, we need to take the value which is 27 minus 2. Okay, 27 minus 2, you get a 25. Okay, which means so the latest finishing time at this note 5 will be 25. Okay, and then likewise, you need to get that the latest finishing time at this point. So 27 minus 8. So latest finishing time you obtain 19. Okay, at this node. Okay, next, you're going to do the same things again. You take the 27 minus 5. So you get a 22. So at this point, you get a latest finishing time. Okay, latest finishing time is which is 22. Okay, now when you come to this part, so we have a two option. Okay, you have a two option, but however, you need to take that for this case, we need to take that the minimum value of that latest finishing time. Okay, minimum value of that latest finishing time. Okay, so now, all right. So in order to check that latest finishing time, so we need to calculate first. You can calculate here. All right, right. If you take that 22, okay, minus 3, how much you get? 19, right? Okay, 22 minus 3, 22 minus 3, you get a 19. Okay, this is for L. Okay, from if this part. Okay, all right. Now we need to compare. Okay, need to compare. So if you take this part, okay, so in order to calculate, you get a 19. Okay, but however, for the 3, you have another part here as well. Okay, you need to check this part as well. So it means 19 minus 7. So you get how much? 12. Okay, so 12. So 19 minus 7, you get a 12, which is L. So you need to compare which one is smaller, 19 or 12, which is 12 is smaller, then you need to take this. Okay, so how you get that? The latest finishing time for the node 3 will be 12. Okay, now next, once you've done this, you need to check over between these two. Okay, between these two. Okay, in order to calculate the latest finishing time here, so you need to consider there are two paths here. One is F and another is a D. Okay, so you need to calculate that both of it. Okay, as we know that the latest finishing time at node 5 is 25. So 25 minus 3, 25 minus 3, so you get a 22. Okay, but remember, you need to check as well this part, which is the activity D. You need to check whether which is the lowest. Then the lowest will be, you need to stick with it. Okay, so for latest finishing time for the activity 4, activity D is a 22. Okay, activity at node 4 is a 22. So 22 minus 6, you get a how much? 16. Okay, so this is 22 minus 6, you get a 16. So which one is lower? This or this? This lower, right? Obviously. So then you need to stick that the latest finishing time for this case is a 16. Okay, so you need to choose this. Okay, okay, moving on. Now we're going to look for that here. Very simple. We have two options here. So latest finishing time, we know that is a 12, is a 10. Okay, so L is 12 minus 10. Okay, so we get a 2 that 2 here, 2 days. And if you take the 16 minus 8, so we get an 8. Okay, 16 minus 8, we get an 8. So we need to check which one is smaller. 2, right? So that means L equal to 2. Okay, all right. So this is how we need to first you need to design the critical path for that this problem. Okay, so earliest time and finishing time. Okay, so automatically we know that the earliest finishing time for the node 0 is a 0. Okay, we already said that earlier. Okay, if you can still cross check the 2 minus 2, you get a 0. Okay, it has to be balanced. Okay, guys, it's clear? Okay, now next we need to check that the critical path, so you can do the double line. Okay, so critical path will be here, here, and then here, which means your activity A, C, H, and J is we call as a critical activity. Okay, they call a critical activity. Okay, A, C, A, H, and J is a first is critical path, and these activities are critical activities. Okay, the critical activity. That means we cannot delay. Okay, you cannot delay any of these activities, which is if you done so, it will affect that entire the project. Okay, it will affect that entire project. Okay, so this must you need to pay attention on these activities. Okay, all right.